Solving a system of nonlinear inequalities is our next little video. Graph the solution set to the system. So let's take a look at what these two figures are. Well, if I look carefully at this right here and I pretend like it's an equals, I can tell that it's a circle. Right? It's a circle. If I look at this one, obviously it's a line. And so I'm going to have a system where I'm going to shade somewhere around the circle, either inside or outside, and then I'm going to have a line, then I'm going to shade either one side of it or the other, and the intersection of those shades will be the solution. Okay, so it says to graph the solution set. All right, let's take a look at the first one. Clear these distractions off of there. And here we go. So this radius for my circle is 5. My center of my circle is at 0, 0. Okay, so there's 0, 0, and the radius is 5. 1, 2, 3, 4, 5 in every direction. Obviously, I'm not going to go 5 in the diagonal because I'm not sure how to count that accurately. All right, now this looks a little wider, looks more like an ellipse, but I'm going to trust that when it records and publishes that it'll straighten out. So this is really a circle with a radius of 5. Okay, close enough. So now let me see which way I'm going to shade this. If I put in a point 0, 0, 0 squared plus 0 squared is definitely not greater than 25. And oops, good night, nurse. What I just noticed, my bad. I just noticed it's supposed to be dashed. Forgive me. So here we go. Dashed, because it's greater than, not greater than or equal to. So there's my boundary. Now I am going to doing the test point check. I'm putting in a 0 for each of those. So is 0 greater than 25? It's certainly not. So that means that the 0.00 is not in the solution set. So I'm going to color outside, which is where the true side is. Okay, now the boundary of the circle is not part of the solution either. Okay, let me come down here. Again, I'm trying to make sure I remember to shade before I go to the next figure. I think it'll make it easier. Okay, so there's that. Now let's take a look at the next one, and that's just this line right here. This line, I'm going to pretend like that's just an equals in order to get the line on there, and that's y equals 0. Well, y, any line that has a y only in it, right, is going to be a horizontal line. So it goes through the x-axis because that's where y is 0. And it's a solid line, so I made that solid, right, because this or equal to. And then now I go back to the original one and see it says anything greater than the line, or in other words, if I do a test point. Now on this one I cannot do a test point. I can't check a test point of 0, 0, right, because that's on the boundary. So I'm going to pick a test point, I don't know, I'll pick the test point over 1, up 1, right? Just make it nice and easy. And so then here's my original inequality. Now I only have a place to put the y, so I'm going to go 1 greater than or equal to 0, and is that a true statement? Is this test point in the true side of my line? And it is true that 1 is greater than 0. Okay, so this must be the true side. And so I'm not going to shade below, I'm going to shade above. Okay, so let's go ahead and do the yellow, and we'll look for the green to be the answer. There's the yellow, it's going to be above, and the green is the answer. Okay, so there's my answer set. Solution set is green. One more, and then we'll be through with this illustration. Let's take a look at this absolute value inequality. Well, I know that this really, I'm going to pretend like it's equals. I know that this right here is the parent graph, and I know that it has the shape of a V. Okay. Well, I know that this right here is an adjustment of that parent graph, and it's a movement to the right 4. So I'm going to take that origin, and I'm going to let the vertex, or not the vertex, but the turning point, it's going to be over 4. Whoops, yeah, solid line. Almost forgot to check what kind of line. So here's my first one. Okay, and then we're going to see what we're going to shade. It says greater than or equal to. I'm thinking it's right up here, right? But let's just double check with a test point, and I'm going to use the test point 0, 0, right? Because it's clearly not on the boundary. 0 greater than or equal to 0 minus 4, absolute value. I get 4 on the right. Is 0 greater than 4? No. Okay, so I see that that point is on the false side, so I'm going to shade in here. Okay. Greater than. Okay, there's that. Okay, and of course that goes on forever. Okay, let's take a look at the next one. And this is a parabola. It's just like this parent graph, right? Parabola. There's no adjustment. It's going to be at the origin. So let me go ahead and change colors here. Let's put this parabola on. And it's going to be a solid line. So if I had my vertex here, I'm going to go over a 1 up 1. I'm going to go over 2 up 4. I'm just getting the basic shape of a parabola that's not been adjusted. Oops, there's that. And then over 3 up 9, right? 1, 2, 3, 4, 5, 6, 7, 8, 9. So there's my thickness of that graph. And here it goes over here. Okay. And 3 out from there's that. Better keep it going up there. Okay, so there's my parabola. It's a solid line. And again, I go back to my original to decide a test point. I'll go use that one. Don't use the equation. So I'm going to use, I can't use the test point 0, 0 because that's clearly on the boundary. So I'm going to use the test point, I don't know, go over -5, 0. Why not, right? I'm going to go over here, -5, 0, and see what I get. That's not -5, 0. There's -5, 0. Okay, so I'm going to put in -5 into my x, square it, and see if that's greater than 0, and it definitely is. Okay, so then this is where we're going to shade on this one outside here. This is the true side of the parabola. However, the part that is the solution set, of course, is the green. So, kind of interesting solution set there, right? Okay, so the green is the solution. I hope this was helpful. Thanks for watching.